Good afternoon, class. Today we are going on to chapter 7 of your E-Maths, Applications of Trigonometry, and it's found from page 213 to page 218. Okay, now let's do some recap first. Now in Sec 2, we learned about angle of elevation and angle of depression. Now for angle of elevation, if it's with respect to the eye level, the horizontal line upwards, this is called the angle of elevation, and for angle of depression is from the horizontal line downwards. Okay, so I repeat again, for angle of elevation is from the vertical line upwards, and for angle of depression is from the horizontal line upwards, and for angle of depression is from the horizontal line downwards. Okay, it is always with respect to the horizontal line. Okay, so if it's upwards is elevation, if it's downwards is depression. Okay, so this can be found on page 213. Okay, I'm going right now into work example 1, which is a revision of your Sec 2 work. Okay, now it tells you that a window of a building is 50 meters above the ground. Given that the angle of elevation of the window from a point on the ground is 42 degrees, find the distance of the point on the ground from the foot of the building. Now, usually we do not draw the whole thing, we just draw a triangle, a right-angled triangle, and take note that the distance from the foot of the building to the point is BC. So if we use sine, cosine, tangent, toakaso, you'll realize that I have to use tangent in order to find BC. So I use tangent, I do the necessary multiplication, and then I will get the length of BC as 55.5 meters. Okay, 55.5 meters. Alright, so that will conclude your example 1. Okay, next we are going on to example 2. Now, example 2 says this. There's a cliff. Okay, there's a cliff of height 65 meters. Given that the angle of depression of a boat from the top of the cliff is 32 degrees, find the distance between the boat and the base of the cliff. Now, as what I've said in the beginning, angle of depression is horizontal line downwards, so this is 32. Now, if this is 32 degrees, this will also be 32 degrees because these are alternate angles. Okay, these two are parallel lines, these two are alternate angles. Okay, so in order to find this distance from the boat to the bottom of the cliff, that means BC, I'm still applying tangent. So tangent 32 degrees is this, and then you do the necessary multiplication and give the answer to 3 significant figure, which is 104 meters. Okay, now I just want to take note here that the angle of depression of B from A is 32, and in another way to say is that the angle of elevation of A from B is 32. Okay, so there are two ways to look at this particular angle. Angle of depression from here and angle of elevation from here. Can you see that it's all with respect to the horizontal line? Okay, that will conclude your example 2. Take note that this part is a revision of your right-angled triangles from your Sec 2 work. Okay, now we are now moving on to exercise 7a. Now, this exercise 7a, I will leave it to you to do the practices, okay, because all the questions are based on sine, cosine, tangent of right-angled triangles. Right-angled triangles. That means we either use sine, cosine, or tangent. Take note that sine is opposite over hypo, cosine is adjacent over hypo, and tangent is opposite over adjacent, and is always with respect to a certain angle. Okay, we can let the angle be theta or any angle that is stated in the question itself. Alright, now for this particular exercise, you are just to do question 9 and question 11 in the notebook. Okay, question 9 and question 11 in the notebook. Now, the next part will be going through question 9 and question 11. Please do not look at the video yet if you have not done question 9 and 11, because this is for your checking of answers. Okay, now let us all look at question 9 now. Question 9 says that an overhead bridge has a height of 5.5 meters. The angles of elevation of the top of the bridge from 2 points P and Q on the ground are x degrees and 23 degrees respectively. You are supposed to find the value of x. Okay, you're supposed to find the value of x. Alright, now for this particular question, we are going to apply tangent 2 times. Now, can all of you look at this big triangle here? Okay, tangent 23 is 5.5 over QR or RQ. We can find it as 12.957. Now, then we look at this smaller triangle, TRP. Okay, we can find this length here, PR. When we take 12.957 minus 5.1, I get this particular length here. And tangent of this angle X is this over this, so it's 5.5 over this. Now, if you key in your calculator, you will get your x degrees as 35.0 degrees. Okay, and since they want the value of x, x is just a value without the units, that's the degrees. Now, bear in mind that for angles in degrees, we are supposed to give it to 1 decimal place round off for the final answer. Okay, that will be your answer to question number 9. Okay, next, question number 11. Now, I just want you to take note that for question number 11, the diagram is not given to you. So it's always useful to draw a diagram yourself so that you can visualize the question better. Now, from the top of a cliff, 88 meters, the angles of depression of 2 boats due west of it are 23 and 18 degrees respectively. Calculate the distance between the 2 boats. Now, I'll let the boat be A and B. Alright, now they say that the angle of depression, so is from the top to the boat A and boat B. Now, I want you to take note that this angle is the smaller angle, so this should be 18. This is the bigger angle, so this will be 23. Now, by alternate angles, this will follow to be 18, this will follow to be 23. Now, I'm going to use tangent for this big triangle. I will get AC as this answer, and I will use tangent for this small triangle. Tangent 23 is 88 over BC. I'll find BC. So the distance between the 2 boats is actually the distance of AB. So I will take AC minus BC. I will get the answer as 63.5 meters. Okay, so this is how we visualize question 11. Now, take note that a diagram should be drawn for you to visualize the question easily. Okay, so that will be for your section 7.1 on angles of elevation and angles of depression. Okay, now let me just reiterate. For angles of elevation and angles of depression, it is always taken with respect to the horizontal line. Okay, alright, now I'm going on to just the basics of bearings of section 7.2. This is found on page 219. Okay, page 219 to page 227. Now, the more difficult parts of bearing will be done in the next lesson, not in this lesson. I just want you to know how to take bearings from certain points. Okay, now, let me just go through the basics first. Now, bearing is always measured from the north line. Okay, the north line is always the one that is pointing vertically. Okay, now, for example, the first one, bearing of A from O is 70 degrees. Now, bear in mind, A from O, once you see this from O, the north line must be at O. Then you join O to A, and this will be the angle. It's always measured with respect from the north line. And bear in mind that for bearing, we give it to 3 digits. So if it's 70 degrees, it will be 070 degrees. Okay, now let me give you a few more examples. Now if you want to find the bearing of B from O, the north line must be at O, join O to B, and it is measured from the north line here. So the bearing is 110 degrees. Okay, now let me give you another example. The bearing of C from O in this third one. Now you realize that C is here, O is here. Bearing of C from O, that means the north line must be at O. Okay, then you join O to C. Now remember that bearing is always taken from the north line, so it's this whole angle. Now if you find that this whole angle is actually this value to 3 decimal place, when you give the bearing, you should give it in this manner. 3 digit, okay, for the bearing itself, but because angles are supposed to be given to 1 decimal place, so this will be the final answer for the bearing of C from O. Okay, 3 digit, but if it's not exact, it must have 1 decimal place round off. Okay, so let me summarize this for you. Bearings are given to 3 digits, and if the bearings are not exact, they are to be given to 1 decimal place. For example, this 251.6 degrees or 015.4 degrees. Okay, bear in mind that bearings are to be given to 3 digits. If it's not exact, then it has to be given to 1 decimal place, like that. But the first 3 must be 3 digits. Okay, so this is how you write your bearing. Okay, now I'm going to give you some more examples here. Let's look at this particular one. Bearing of A from B. Now you realize that it's from B, so the north line must be at B. Then you join A to B, then you start from the north line all the way. This angle will give you the bearing of A from B. Okay, likewise, if I have the same 2 points, but now I change the question from bearing of B from A. So from A means the north line must be at A, and I join A to B and start from the north line. I have this angle. This will be the bearing of B from A. Okay, so I repeat. When it's from A, the north line must be at A. When it is from B, the north line must be at B, and the angle must start from the north line all the way to the line where you connect your A and B. So this is how we find bearing of a certain point from another point. Okay, now let's look at example 3 on page 220. Okay, they give you a figure and the first question is to find the bearing of A from O. Now from O means I need to look at this line. Okay, I need to look at this line. This is the north line. Alright, this is the north line. A from O, so it's just this angle here, so it's 055 degrees. Now bearing of B from O. B is here, O is here, north line is still here. Now you will have to realize that I have to take the whole of this angle, because all bearings, the angles must be taken from the north line. So bearing of B from O is this whole angle. Now how did I get this? Now you realize that from here to here is 270 degrees. That means this whole angle here, this whole angle that I've shaded is 270, and when you plus 25 you will get the whole angle, so it's a 295 degrees. Okay, now next is the one that you have to pay attention to, because it's the other way around. Now bear in mind that O is here. What is the bearing of O from A? Now if this is the case, bearing of O from A here, that means my north line got to be at A now. Okay, and this is the line joining O and A. I got to find this angle. Alright, now if I extend this, you'll realize that this one is 180, and by alternate angles this is 55. So 180 plus 55 will give you a 235 degrees. Okay, last part, the bearing of O from B. Now, bearing of O from B, that means now my north line has to be at B, and I'm supposed to find this angle. Okay, now how do I find this angle? Okay, now everybody knows that this is 90 degrees. Okay, now if I extend this, this will be 25 degrees because of alternate angles. So if I take 90 plus 25, I will get this whole angle, which will give you a 115 degrees. Okay, so that will be your example 3. Now I just want to reiterate that if the bearing is from O, the north line must be at O. If the bearing is from A, the north line must be at A. If the bearing is from B, then the north line must be from B. And all bearing must be taken from the north line onwards. It's measured starting from the north line. All of you must bear this in mind so that you can get the bearing correct. Okay, now the next part, okay, can you all please do your exercise 7b? Okay, exercise 7b, question 1, 2, 3, 6 and 7 in your notebook, and you check the answers with the back of the textbook. Okay, check the answer with the back of the textbook. Alright, so please do this in your notebook first before you check the answer. Now, I want you to pay attention to question 7. Okay, because there are 2 sets of answers. Alright, now I will not go through 1, 2, 3 and 6, okay, but I will go through question 7. Okay, now all of you turn to question 7, which is found on page 226. Now the question says that P, Q and R are 3 points on level ground. Given that the bearing of R from P is 135, angle PQR is 55, and angle PRQ is 48 degrees, find the bearing of the following. Okay, now these particular questions did not provide you with the diagram, okay, but in fact there are 2 cases here. Now the 3 points can be in this particular manner. Okay, that is your case number 1. The 3 points can be in this particular manner. That is your case number 1. Okay, now take note that bearing of R from P is 135, so it's here 135. Angle PQR is 55 and angle PRQ is 48. So what is the bearing of P from R? P from R means that I will have to take P from R will be this whole angle here. Okay, now I want you to look at this. This angle and this angle and this angle here, they are interior angles, parallel lines. So if this whole thing is 135, this will be 45. Okay, this will be 45. Alright, so in order to find this whole angle, I'll have to take 360 degrees minus 45, I'll get a 315 degrees. So the bearing of P from R is 315 degrees. Okay, now next, I'm going to find the bearing of Q from R. Q from R means that I am just finding this angle here, this small little angle here. Okay, now just now we found that this is 45, this whole thing is 48, so this little angle will just be 48 minus 43, which will give you a 3 degrees, but bear in mind that it has got to be 3 digits, so it's 003 degrees. Okay, last, the bearing of P from Q. Okay, Q is here, the north line. P from Q means I want this whole angle here. Okay, now everybody knows that this is 3 degrees from just now. If this is 3 degrees, this will also be 3 degrees. So I just have to take, this is 180 plus 55 plus 3, I'll get this whole angle. So you get a 238 degrees. So this 3 will give you the answers for case 1. Okay, now the diagram need not be in this particular form. It can be in the case 2 form, whereby the 3 points are drawn in this manner, and it also works. Okay, and it also works. Alright, so let's take a look at case 2. Okay, case 2, if I draw it in this manner, the bearing of P from R, sorry, is here. Now this is 135, this is 45, because this and this are interior angles, add up to 180 degrees. So I just have to take this whole angle here, this whole thing, which means I take 360 minus 45, 315 degrees. Okay, that is your first part. Second part, bearing of Q from R. Q from R, that means I want here, this angle until here. Okay, now if I want this black angle here, okay, I need to take 360 minus 45 minus 48. I will get this. So I'll get a 267 degrees. Okay, bearing of P from Q. That means I want this angle here. Alright? Okay, now how do I get this angle? Now, look at this. This is 55, this is 48. It will give us this as 77. This is by angle sum of triangle. Then by angles at the point, I can get this particular angle here as 148 degrees. Therefore, I can get this angle because they are interior angles, parallel lines. So I will have 180 degrees minus 148. I will get this angle here, which will give me 32 degrees. But I got to add a 0 in front because all bearings are to be given to 3 digits. All bearings are to be given to 3 digits. Okay, so this will be your second set of answers. Now realize that in both sets of answers, the bearing of P from R are the same. The bearing of P from R are the same, but part B and C will differ depending on whether you're referring to case 1 or case 2. Okay, so that will conclude your section on the simple types of how to read bearings or find bearings from a certain point to another point. Okay, now the next section that I'm going into, that will be your next lesson, not this lesson, will be the more difficult questions on bearings, whereby we have to use either sine, cosine or tangent. We may even have to use sine rule and cosine rule, or area of triangle that you have done in chapter 6. Okay, that's all for this lesson. If you have done all your notebook homework, then there's no more homework for you, but you please read through the section on bearings so that for the next section that I'm going to, it'll be faster for all of us. Okay, thank you class.